Okay, so we're looking at the length of a rectangle and the width, and determine the algebraic expression for the area in simplified form. So this is really sort of a model of how we can consider multiplying binomials together, or any polynomial. Okay, so the area is length times width. We're told what the length and width is. So in this case, it's 2x plus 5 times 4x minus 3. Okay, it says determine the algebraic expression for the area. So that is in what we call factored form. Now, I want you to expand that out. See if you remember from yesterday how to distribute. So you'll have 4 terms to start. Collect like terms. I'll give you a minute to do that. The writing's a little bit big here, but right, so you should have 4 terms, the 2x into everything in the second bracket, and then the 5 into everything in the second bracket. So that's the area in expanded and simplified form. If we use the word expand, that should be a real clue that you've got to get rid of the brackets, but sometimes we don't. We just say simplified. So simplified form never has brackets. So just try to remember that, because we're going to look at factored form last week. Simplified form, you multiply through, no more brackets, and you collect like terms. Okay. Now, if we're finding the area when x is 3, so now I'm going to substitute in 3 for every x. I wanted that to be red. Okay, and now do the order of operations on that. So this is really, that was from part A. Okay, so now 3 squared is 9, times 8 is 72. 14 times 3 is 42, minus 15. So what's that? 110, 114 minus 15 is 99. And that would be centimeters squared. Okay, because x was centimeters. So what are the dimensions of the rectangle? Well, we go back, the length was 2x plus 5, and the width was 4x minus 3. Okay, so we put, wherever there's an x, we put 3. So 3 goes there, 3 goes there. So that is 6 plus 5 is 11 centimeters. Width 12 minus 3 is 9 centimeters. And does that make sense? Is 11 times 9, 99? Yeah. So it's a way of checking your work. You're not going to always have time to just substitute numbers into check, but it is a way, it is a different method of verifying your expansion, right? So if I put 3 into the length and width here and I didn't get 99, then I'm probably expanded incorrectly. Right? So it is a method, but after next week we do factoring, and they are opposites. So that's another way that you'll be able to verify for some polynomials. Okay. So next one, a triangle has a base equal to 2x plus 8 and a height equal to x minus 2. Determine the algebraic expression for the area of the triangle in simplified form. Hands up. What's the area of the triangle? We do expect you to know this. Seth?
Base times height divided by 2.
Right. Base times height divided by 2. Okay. Or you could show it as 1/2 base times height. Either one is fine. Okay. So here, if I do base times height divided by 2, look like that. If you put the half out front, it'll just be out front. But you have to expand and simplify. So multiply through, get rid of the brackets. You do that right now. If you struggle to remember what to multiply, remember we talked about that word FOIL. It's an acronym. It's not a mathematical method. I mean, it's a way of remembering what to do. So F stands for the first terms in each bracket. O stands for the outside terms. I stands for the inside terms. L stands for the last terms. So first, outside, inside. Oops, it didn't change color. Inside, last terms. So that would be 2x squared minus 4x plus 8x minus 16. Okay, collect like terms on those middle terms. So the negative 4x plus 8x are like terms. So another case, right, this unit where you have to be good at your integers. And now we're dividing by 2, right? So we still need to simplify. If you take a look, every term there has an even coefficient. So that means 2 goes into every term. Sometimes I'll show you what I do. In order to divide 2, it has to go into everything. So I need to see, I kind of do a little fan out, okay? And it has to go into all of those. If it does, then you divide into all of those. If I only had one of those green ovals and it didn't work in the other ones, then I couldn't divide out. I would just leave it. But this now will be x squared, or 1x squared, plus 2x minus 8. Right? 2 divided by 2 is 1. 4 divided by 2 is 2. Negative 16 divided by 2 is negative 8. So that's the area of the triangle in simplified form. So that's sort of a area of rectangles, triangles, that kind of thing is a common application type question for multiplying polynomials. Who, back in junior high, ever used algebra tiles? Okay, hands up. Yeah, so probably a fair number of you. So we're going to touch on it, but we don't touch them. We're not using algebra tiles in 10C. That's kind of a middle school introduction to them. But if it helps you remember what to do, then certainly you can visualize it. But we're moving on to not having to use manipulatives for multiplying. We expect that understanding already. So what's an easier version is just thinking about the area of a rectangle in general, without getting the algebra tiles out. If you remember back, you had big squares, which were called x squared terms. You had skinny rectangles, which were x's, and you had little squares, which were constants of 1. And so basically you have to fill in that rectangle. And so here, if I look at this rectangle, these are all the areas of each of the rectangles or squares. So we add them together. So these are like terms. So we've got 3x squareds. We've got 1, 2, 3, 4, 5, 6, 7 x's. Let's use purple. We've got 2 1's. So the area of the rectangle is 3x squared plus 7x plus 2. Now, what is the length of that rectangle? So if we look at the length here, what we divided into the parts, so we've got 1x here, 1x here, 1x here. So that's 3x plus a constant of 1. So the length is 3x plus 1. What's the width? So here we've got 1x plus 1 plus 1. So that's x plus 2. Okay. So the area can be expressed as length times width. 3x plus 1 times x plus 2. Again, with the brackets, it's called factored form. And then expand that out. Hopefully, when you expand that out, you get the area that we had right here. Okay, so you do that right now and make sure you get the same thing. First terms together. Outside terms together. Inside terms and last terms. So 3x, so 3x squared plus 6x plus x plus 2. Okay. So that's 3x squared plus 7x plus 2. And that's what we got originally from our diagram. Okay. Remember, if it's just x, that means 1x. So this example shows the simplified form of the product of two binomials. Remember, binomials have two terms in them. So two brackets, each had two terms in them. So as you can see, to get the simplified form for the product of two binomials, the total area, you can either count up the areas of the individual tiles, or you can use distributive property. Which is really multiplication. That's kind of messy, sorry. Let me just make that tidier here a sec. Okay. Okay, so what would you do for the algebra tiles? It says multiply 2x plus 1 times x plus 3 using algebra tiles, and then the area model. So really, area model I tend to use more, okay, because it's a little bit easier than separating. So I'm going to do that one first. So in the area model, I kind of erase these parts. I just want the rectangle. So I draw my rectangle. Okay. And then I'll have 2x plus 1 here and x plus 3 here. Okay. Now, what you might want to do is separate that a little bit. So 2x, so I put the 2x kind of here, so this would be 2x and 1. And I draw a line down. Oops. Okay, and so that would be cut in half. And then I have x plus 3, so I might do the same here, x and then 3, okay? And so that should make square there. These are each x's, so this would be your x squared, this would be x squared, and this would be x times 1 is x. Again, 3 times x is 3x. 3 times another x is 3x. And then 3 times 1 is 3. So now if I add those up, I would get 2x squared plus 3x plus 3x plus 1x is 7x plus 3. Okay, so that's using an area model. The algebra tiles, even more shapes that you have to put in. So I'm just going to show you what it is here. So we have x, x1. We have x here. 1, 2, 3. Now it's nice if you have a ruler and you make them equally spaced, but if you look here, then you'll have x squared, x. This 1 times x is x. These rectangles are all x's, and these are all 1's. And so you get the same thing, 2x squared plus 7x's plus 3. So mine's pretty squiggly. I've seen some of your work. It's even more squiggly. So good to use a ruler. Basically, I don't think we'll be asking you to specifically use algebra tiles. Maybe we might give you a question where you're given a diagram with algebra tiles, but not that you have to draw it, okay? So you have to understand what it represents, but not that you would have to draw out the lines, right? We're in grade 10. So that's not, that's kind of junior high stuff. All right. Then, okay, so then you'll see that there's practice in there. And then the next section is multiplying part 2. So yesterday I asked you to try to do some of the practice for question 1. Not question 2, because it was area and algebra tiles. So hopefully you did that. I'm kind of expecting that you did. So we're going to look at multiplying part 2. Again, the first question is review. So start on that right now. Just going to set up a new video. So multiplying polynomials part 2, you're doing question 186.